So I wanted to take a minute to go over this key that I made for the eutrophication lab with you, and feel free to let me know if you have any questions about it. So this describes some of the background about the ecosystem, which is a salt marsh, the researchers, and the questions they're trying to answer, and also their hypotheses about um, urbanization and its effects on the salt marsh in a particular estuary. So that was their big research question. And if you read through this background information, you start to understand that their hypothesis, which they tested, was about how the oxygen levels were differing in an area of the marsh where there was urbanization in the upper marsh versus areas that were further away. Um, so this page was just kind of asking you to show your understanding of how we would expect urban runoff or urbanization to affect an aquatic ecosystem. And with with less runoff, like in the lower estuary in this situation, we would expect less nutrients. And the big nutrient polluters in aquatic ecosystems are going to be nitrogen and phosphorus. When there's not a lot of nitrogen and phosphorus, there's not excessive plant and algal growth. So I didn't draw any extra plants and algae here. With low amounts of primary producers, there's not going to be a lot of decomposition. And we know that that's a process that draws down oxygen. So without a lot of decomposition, we would have more oxygen. And that's going to support oxygen demanding animals like fish. So I drew more fish in this picture. In the upper estuary, on the other hand, this is where we expect to see some of the impacts of urban runoff. There would be more nitrogen, more phosphorus. So I drew more primary producers, which are going to thrive when there's more nutrients. With greater decomposition of primary producers, we're going to have less oxygen. So I just drew one kind of crummy looking fish, representing that these conditions can be difficult for animals to live in. On the next page, you were asked to fill in this data table with the fluctuation in dissolved oxygen. I just subtracted these two numbers to get these numbers in the right-hand column. Then you took a mean for dissolved oxygen at dawn and at dusk based on these numbers in the chart. So for the upper estuary, to get this dawn mean of 8.2, you would just take the average of these three numbers. For the lower estuary, to get this dawn mean of 9.6, you would take the average of these three numbers. Over here, this was the fluctuation, mean fluctuation. So for the upper estuary, it would be an average of these three numbers. For the lower estuary, it was an average of these three numbers. On the next page, we graphed the data, but here we were asked to describe the independent and dependent variables. The independent variable here is going to be the location that was sampled, either the upper or the lower estuary. The dependent variable is going to be one of these data points around dissolved oxygen, whether it's the dawn dissolved oxygen, the dusk, or the fluctuation. What I did here is I graphed the mean daily fluctuation in the upper versus lower atmosphere. We can see that there was greater fluctuation in the upper compared to the lower estuary. That's a sign that the runoff is having an impact. The oxygen's getting drawn down more overnight when the plants are not photosynthesizing as a result of decomposition of all these primary producers in this nutrient-rich environment. We see lower fluctuation here. And we kind of see the same pattern, although to a lesser extent, when we look at the dawn oxygen levels in the upper versus the lower atmosphere. They got drawn down further in the upper estuary where we have the impacts of urbanization as a result of more nutrients, causing more primary production, causing more decomposition, which draws down the oxygen relative to what we're seeing in the lower estuary. And then finally, I just kind of answered these questions based on the data. Um, I think the claim here that answers the scientific question that we talked about at the beginning would be that urbanization and the associated runoff will cause eutrophication of aquatic habitats, including estuaries. And their data support that, looking at just dissolved oxygen, seeing greater fluctuations and lower levels in dawn where they did have effects of urbanization. Um, then you were asked to um, let's see. Then you were asked to find evidence that supports that claim. So that would be the greater fluctuations in dissolved oxygen in the upper estuary. It would be the lower dawn values, which are showing that there's more decomposition occurring overnight in these habitats, which is probably associated with the nutrient runoff in the upper estuary. This is kind of more of the same. Um, Here you were asked to explain if you thought the data were inconclusive. They are not that compelling. I mean, these means are probably significantly different, but we're not seeing huge differences. So I could see an argument either way for that one. And then your next steps as a scientist, what else would you want to do? What other questions would you try to answer? My argument here is that there are a lot of other indicators of eutrophication besides the dissolved oxygen level. So maybe the researchers should look at some of those indicators, like the amount of algae and plants that are growing in these two locations, the amount of fish that are growing in these two locations, and maybe they should actually measure the nutrients in the water to show that that really is that there really are more nutrients in the upper estuary compared to the lower estuary. So there's a bunch of other kinds of work that could be done in this study, in this particular study system.